right, well, hopefully everyone can hear me. I'm going to begin the webinar now. If there's any questions, please type it. If there's audio issues, let us know. Thanks for joining us today and for attending a discussion on our capabilities in biomedical and life science applications. My name is Ryan Flaherty. I'm the Regional Sales Manager for the East Coast of Avantes. And joining me today is Damon Linsky, our General Manager for Avantes North America. And also joining us will be Justin Spott. He's our Central Regional Sales Manager. Justin will be the Q&A coordinator today. So if there's any questions, feel free to type them into the question box found on the GoToMeeting application. You can see it there. And he'll do his best to address your question and get back to you as soon as he can. So to give you a brief introduction to Avantes, this year we're celebrating 26 years in the fiber optic spectrometer industry with an install base of well over 35,000 spectrometers, ranging from research applications to OEM. Our headquarters is in Apeldoorn in the Netherlands, with our North American headquarters in Louisville, Colorado, just outside of Denver. And finally, we have Asian office and operations in Beijing and Shanghai, China. Where we don't have direct offices, we have a distributor network of more than 40 worldwide distributors in countries such as Japan, Australia, and France. Avantes is part of the Dynamic Photonics Group, a publicly traded company on the German Xetra Stock Exchange, and we are one of a number of photonics-related organizations offering a wide variety of solutions to the life science, research, and industrial market. We also have a great demo program that we urge our customers to take advantage of. This allows you to test drive a spectrometer. We have a bunch of spectrometers available on our website, so if you have an application in mind and want to try one out, we're more than happy to ship one up to you and try it out for a week and get some data from it. We find this is especially important nowadays with the COVID situation, where our sales team is not actually able to get in and visit our customers, that we can still let you try the spectrometer out. One thing that sets Avantes apart from our competition is our dedication to quality. We strive for continuous improvement in all of our manufacturing and management processes. As such, we're an ISO certified, ISO 9001:2015 certified company, and we routinely undergo audits and management reviews both internally and externally. All of our spectrometers come with a 3-year limited warranty, and with this we have full subcomponent traceability, meaning that all the optical components, the gratings, the mirrors, and electrical components can be traced back to their origin in the quality control data. Some of our applications call for the spectrometer to be radiometrically calibrated, and for this we have labs in both the Colorado and Netherlands office to accomplish this, including the ISO 17025 calibration procedure. At Avantes, we realize that in biomedical and OEM applications in particular, the continuity between spectrometers is key. And this is why we've developed a semi-automated manufacturing process for our AvaSpec mini-series. This gives us the ability to ramp up production very quickly, driving both down manufacturing costs and time and reducing the human error in the build process. This also benefits from statistical process control, so we can assure you that the first spectrometer you purchase from us will match up to other ones that you purchase years from now. And now I'd like to hand it off to Damon, who's going to discuss some applications where these products have been used.
Thank you, Ryan. I appreciate that. Today, we'd like to share with you just some of the many spectroscopy applications where spectroscopy is actually used in life sciences. And these are just a small list of some of the examples to start with. Blood analysis, probably one of the more common. This is a visible range application where blood gas analysis is occurring, and I'll talk about that in more detail in a subsequent slide. Pulse oximetry, while this is typically done and performed using sensors, these sensors and the instruments can be tested or used for a validation with a spectrometer and also for component quality control. So spectrometers come into play there. Cancer detection, typically fluorescence or diffuse reflection measurements can be used to identify proteins as well as characterize mass structures. This can be done in the UV on out into the visible and even in the near infrared. Proteomics, the large scale study of proteins, is also typically performed in the UV. This can be a fluorescence type measurement or absorbance. And there are also examples of Raman spectroscopy being applied to the field of proteomics. And then the area of skin diagnostics, and this is basically dermatological assessments for underlying conditions. So I'll be going into some of these in more detail in subsequent slides, but I'd like to start with understanding the benefits of optical spectroscopy and why it's a good technique to consider for medical device and life science applications. Well, first of all, optical spectroscopy will facilitate in vivo or ex vivo measurements. So particularly with the fiber optic interface, it's quite simple to be performing a measurement during a procedure or during a surgery, and the fiber optic interface allows for sampling at a very small scale within, like I say, within the in vivo environment or ex vivo outside of the patient. It's also oftentimes a non-destructive sample, since frequently we're working with incoherent light sources and their interaction with matter, and so we're measuring reflections and fluorescence off of tissue samples. So it's quite suitable and not non-destructive, allowing for multiple measurements of the same sample. It also is common that there's minimal to no sample preparation. So again, based on the fact that we're measuring frequently fluorescence and reflection measurements, no sample preparation is required. And it's a real-time analysis. So the speed of these instruments from which they can acquire data, send it to a CPU for processing and provide an analysis can be in the second time scale. Another advantage of optical spectroscopy is microsampling. So because we're working with fiber optic interfaces frequently, we can measure at the scale of spots as small as 50 microns up to a few hundred microns. And this can allow for sampling over an area with a rastering or multiple scans over an area, but again, at a very small scale. And finally, high-speed sampling rate. And I've alluded to this previously, that because these instruments can acquire data in millisecond timescales, even microsecond timescales, it's not unreasonable to think for sampling in the seconds or a few seconds rate, even with multiple averages to provide improvements in signal to noise. Okay, so I'd like to dive into a few of these applications in more detail, starting with smart biopsy or endoscopy. Now, this is typically a technique, endoscopy and smart biopsy. Obviously, biopsy is a more invasive technique involving a needle and extraction of a sample from the human body. However, this can also, at the same time, a spectroscopic measurement can be taken. So the actual biopsy needle can be fitted with fiber optics within the actual trocar and the cutting edge, and it's quite possible to perform samples of fluorescence or reflection during an actual biopsy procedure. And in the area of endoscopy, the same can apply. So during an endoscopy procedure, reflection measurements can be made during this procedure with a modified endoscopy probe. And again, these measurements can be performed in very high speed in the millisecond time frame, allowing for real-time guidance and analysis during the performance of the procedures. The next area that I would like to talk about is blood analysis, again, a visible range technique. This is blood gas analysis, measuring either whole blood or lysed blood, and a variety of parameters can be derived, obviously hemoglobin, oxyhemoglobin, et cetera, there on the slide. And these instruments with spectrometers within them can be perform online or offline measurements. So inline measurements could include, for example, a heart and lung machine, where real-time guidance to the heart and lung machine can be provided based on continuous measuring of co-oximetry parameters. The next area I'd like to touch on is proteomics. And of course, proteomics, again, is the large-scale study of proteins in under specified conditions. Raman spectroscopy has been used and applied successfully to detect interactions and abnormalities within proteins. And this can be particularly applicable when applied with microscopy instrumentation, where an actual area can be mapped or a sample can be mapped. In addition, UV absorption spectroscopy is effectively being used to quantify proteins, and this is done in the deep UV range in and around 280 nanometers. So there's some spectra there in the lower left that shows an example of that type of an analysis using fluorescence as well as absorbance. In the area of skin diagnostics and mass characterization, this is really looking for skin abnormalities and trying to identify underlying physical conditions. This can range anywhere from measuring the blood perfusion in tissues. So this can be used in the case of, say, a transplanted tissue, skin transplant, to determine the health of those tissues and ensure through an optical measurement, again, non-invasive, painless measurement, whether the underlying tissue is in good condition. Also, specialized probes and integrating spheres have been and can be designed for reflection measurements that allow for near-infrared penetration to underlying tissues to determine the structure of those tissues. For example, in the lower left, you see a variety of the parameters that can be identified, such as HHB, which is going to be the non-oxygen carrying hemoglobin, as well as oxygen carrying hemoglobin, bulk lipids, water content, and this can be used to assess the condition of masses below the surface of the skin. And this is commonly done in the near infrared. So now I'm going to hand it back over to Ryan to talk about some of the commonly used instruments that are used in the life science areas. Ryan?
Thanks, Damon. Yeah, as you mentioned, we've seen great success with the following spectrometer models, just to name a few. The first is the Avantes Mini 2048CL. This features a compact form factor. It's our smallest and lightest weight spectrometer that we offer. So it's great for OEM applications, especially if you're space limited or you have handheld type application. Its low stray light makes it great, ideal for proteomic applications, and it also features a high-speed detector and high-resolution models are available. Featuring a CMOS detector array, it's ready for the future, so we'll have plenty of these in stock for the time. This is also available in the middle spectrometer there, the Avantes ULS 2048CL EVO. This uses a slightly larger optical design, but it benefits from an upgraded electronics card. This is called our EVO electronics card, and it uses USB 3 and gigabit Ethernet connectivity. In addition to the low stray light as well, it has great resolution and sensitivity options, so this makes it ideal for blood analysis applications that Damon mentioned. And then finally, for more demanding applications, we have the last unit there, the Avantes HS 2048XL EVO. This is one of the most high sensitivity systems that we offer. It uses a 0.22 numerical aperture optical bench to match that of the fiber optic cable. So this makes it great for applications with low light, such as fluorescence and diffuse reflectance applications. And this also features the EVO high-speed electronics. And I'll mention that all three of these systems are available in OEM configurations. So not only does Avantes offer spectrometers, but we also offer an entire suite of accessories that would enable a complete measurement solution. This can range from fiber optics, so you can have fiber optic cables to transport light to the sample, or conversely, light from the sample to the spectrometer. We also offer sample interface probes. These can be non-contact reflectance probes or dip probes for liquid samples. And since we're doing all of our own fiber optic manufacturing, we have the ability to customize. If you have a custom probe idea, let us know. We can do custom lengths, custom jacketing options. And then for most measurement applications, they might require a light source to either pass light through the sample or reflect off of it. And for that, we have a number of sources such as LED, tungsten halogen, deuterium, pulse xenon sources. Most of these have optional triggering and shuttering on these as well, in addition to being available as an OEM module. And then finally, to actually measure your sample, some type of sample interface is typically needed. So this can be, either the fiber optic cables or fiber probes that I mentioned, or, it can be a flow cell. This would allow time series or kinetic studies. We also have integrating spheres for diffuse reflectance or temperature-controlled cuvette holders. So I've only touched on a few of our spectrometer offerings, but we have many more optical bench and detector options that we've divided into our various product lines. The first is the Avispec compact line. This is where the Avispec mini spectrometer resides. Great for small form factors. Most of these detectors are also available in the Avispec Star line. This is the version that uses the larger optical bench and increased upgraded electronics. And then for the more demanding applications, we have the Avispec Sense line. These utilize back-thin CCDs with optional TE cooling for the ultimate in sensitivity and signal to noise and low dark noise. The first three product families generally cover the 190 to 1100 nanometer range. So if you want to extend that range out to 2500 nanometers, we have our Avispec Near line for near infrared. These use in-gas arrays of either 256 or 512 pixels and optional TE cooling. So with a combination of these, you can easily cover the full range of 190 to 2500 nanometers. And as an OEM component supplier, we can cover all aspects of the instrument design, including the enclosure. We have a couple enclosures as examples. So any of our spectrometers can be housed in a kind of black box approach, either branded or unbranded. These all include easy mount flanges for easy integration into your instrument machine that you're building. And some customers actually use their own electronics. So if you would just like to use our optical bench and mate to your electronics, that's also possible. We also offer fast prototyping services for custom solutions, which would include the integration of all of our components and accessories. So for example, in the pictures we have here, we've created a small reflectometer system that's easily made by combining a spectrometer and a light source in one enclosure that offers the complete measurement solution. The top one on the left is for non-contact thin film thickness measurement. So inside the box is our spectrometer and a UV visible light source, and the sample is just placed on top. The one on the right towards the bottom, same kind of enclosure, has a Avispec mini along with a halogen light source, and this one features the SMA coupling, so you can attach fiber optic cables or a fiber optic probe, just kind of widening the measurement possibilities. I'd like to also mention that we do have feasibility testing, so if you're not able to take advantage of the demo program of getting a spectrometer in hand, you're allowed to, or you can send us samples to our Colorado facility, and we can run a free feasibility test and show you kind of the different results we can get with the different spectrometer models and different accessories. That way we can prove to you, that the spectrometers will work for your application before purchase. To give you a little background on our technology, Avantes uses a Turney-Turner optical design in our ULS optical bench, and the ULS stands for ultra-low stray light. To give you an idea, the physics of how this works, you have the optical entrance where the fiber optic fiber or probe would attach, and this can be either an SMA 905 or FCPC key connection. The light then goes through a mode stripper to reduce mode effects and will transmit onto the collimating mirror. This then collimates the light onto the grating, which will act as a prism to disperse light onto the focusing mirror. And then the focusing mirror will send the light onto the detector. And before it hits the detector, there may be some order sorting filters, maybe some blocking filters. We can also do some lensing before it hits the detector array. Just depends on the configuration and your application. And finally, to complement the optical benches that we offer, an electronics card is often needed. This converts the photons of light into electrical signal, allowing you to communicate to a standard computer or Raspberry Pi. We have two main boards, the AS5216 and our newer AS7010, which is our EVO board. The first utilizing the USB 2.0 communication, while the EVO board, as I mentioned, uses USB 3 and Ethernet communication. We also have RS-232 protocols. All of our spectrometers have onboard RAM storage. So with our software and our DLL package, you can use the store to RAM mode. This allows you to take a quick burst of data, store it onto the spectrometer, and then send it over to the software to analyze later, saving a lot of time. They all feature digital analog input-output, in particular for process controls such as triggering and shuttering. For example, if you have a laser or a light source, you can send a TTL pulse from the source to the spectrometer, telling the spectrometer exactly when to acquire data. And conversely, you can do the same. You can have the spectrometer send a pulse to your source, telling it when to turn on, fire, and shutter. We also feature high-speed data transfer. A lot of our detectors run at very high speed, so you can collect data in a microsecond time scale. And then finally, I'd like to mention we have a full dynamic linking library, a DLL, or a software development kit. So this allows you just to take, if you don't want to use our software or Avasoft platform, you can take the raw data from the spectrometer and throw it into your own environment, such as LabVIEW or MATLAB. And these demo programs and example codes are available in Windows, Linux, Raspberry Pi, and Mac OS.
Okay, thanks very much, Ryan. Well, I'd like to close by, first of all, thanking you all for your interest in participating in this webinar. To sum it up, Avantes is an ISO-certified manufacturer of optical instruments with 26 years of experience. We offer comprehensive solutions ranging from the instrument to the light source fiber optics, as well as the sample interface. And our instruments are OEM ready. We've been doing this for 26 years, so we know how to work with companies that are building devices from the research phase on up through product development and launch. And we're happy to avail our instrument demo program to you at your request. So please let us know. We look forward to helping bring your ideas into the light. And again, if you have any questions, please feel free to type those in. We're not going to do an actual official Q&A session, rather do it offline. So if you can send in your questions, if you do not get an answer immediately, we'll follow up with you shortly thereafter. Sometimes we get some tough questions that we may not have all the answers for immediately, so we'll research it and get right back to you. But again, I want to thank everyone for participation today, and thank you for your interest. This concludes our webinar.